Okay, so this is 8.4, part 2. Alright guys, so as you saw before, sometimes when you work these identities, they just don't work out right. So once again, stop if you're not getting close to what the other side looks like, and start from the beginning trying something else. Okay, so if I look at this one, establish identity, the left-hand side, which is sine theta over 1 plus cosine theta, plus 1 plus cosine theta over sine theta is the hardest of the two sides. So this is the left-hand side. So our goal is to make the left-hand side look like the right-hand side. So how do we do that? I would first try finding a common denominator. So the least common denominator for this particular identity is sine theta times 1 plus cosine theta. Okay, I'm going to write those denominators down. So since I have 2 of them, I'm going to do this twice. Okay, so initially in the first one I had sine theta. So now that I've multiplied sine theta by the denominator, I need to multiply sine theta by the numerator. And in the second one, I had 1 plus cosine theta in the numerator. And since now I've multiplied 1 plus cosine in the denominator, I need to multiply that in the numerator as well. Okay, so now that I have everything built up, I get sine squared theta plus, and if I FOIL out 1 plus cosine theta times 1 plus cosine theta, I get 1 plus 2 cosine theta plus cosine squared theta, all over sine theta times 1 plus cosine theta. Okay, now if I rearrange this, I can get sine squared theta plus cosine squared theta together. And then I'm going to put plus 1 plus 2 cosine theta. Okay, all over sine theta times 1 plus cosine theta. Okay, sine squared theta plus cosine squared theta, that's Pythagorean identity. Pythagorean identity is sine squared theta plus cosine squared theta equals 1. So I'm going to substitute a 1 in for sine squared theta plus cosine squared theta. Okay, so now I have 1 plus 2 cosine theta, all over sine theta times 1 plus cosine theta. Okay, 1 plus 1 is 2. So now I have 2 plus 2 cosine theta, all over sine theta times 1 plus cosine theta. Okay guys, I almost have something that I can cancel out the numerator with the denominator, but I just have to factor out the GCF. Do you see that there's a 2 in the first term and a 2 in the second term? If I factor the 2 out, I'm left with 1 plus cosine theta. And this is all over sine theta times 1 plus cosine theta. Okay, now I can cancel the binomials out. And I'm left with 2 over sine theta. Okay, if I pull out the 2, I get 2 times 1 over sine theta, and 1 over sine theta by definition is cosecant. So this is 2 cosecant theta. And that is exactly what the right-hand side is, and I know I'm done. By the way, if you're wondering why I'm making little squares after it, that's to let everybody know that I've established identity. I made the left-hand side look exactly like the right-hand side. Okay, next one. Establish the identity. Tangent v plus cotangent v over secant v times cosecant v equals 1. I'm going to try writing this up in terms of sines and cosines to see what happens. And once again, I'm going to work on the left-hand side because I really can't work on the right-hand side. It's 1. I can't substitute. I can't do anything with that. Okay, so tangent is sine v v over cosine v. And cotangent is defined as cosine v over sine v. So now I have sine v over cosine v plus cosine v over sine v. And all I did was use the definitions of tangent and cotangent. Okay, in the denominator, secant v. Secant v is 1 over cosine v times cosecant v is 1 over sine v. Okay, so in the numerator, I'm going to have to find a common denominator. The LCD is cosine v times sine v. Okay, so I'm going to rewrite everything as cosine v times sine v plus cosine v times sine v. And in the numerator, I had sine v initially, and now I've multiplied the denominator by sine v. So now I have sine v times sine v in the numerator. The second one, I had sine v and I had cosine v in the numerator. So now that I've multiplied cosine v by the denominator, I have to multiply cosine v by the numerator as well. Okay, so I'm still working on the numerator. I get sine squared v plus cosine squared v all over cosine v times sine v. Okay, Pythagorean theorem says that sine squared v plus cosine squared v, we can substitute a 1 in there. So I have 1 over cosine v times sine v. Okay, so that's the numerator. Now, I'm going to work on the denominator. So the denominator is 1 over cosine v sine v. Okay, this is shaping up nice because when I rewrite this as a multiplication problem, I take the reciprocal of the denominator. So I have cosine v sine v over 1. And these two cancel each other out. So basically I get 1 over 1, which is 1. That is the right-hand side, so I've established my identity. Okay, so there's another one on the next page, establish identity. And quite honestly, guys, neither side looks easier than the other. So just for fun, I'm going to do the left-hand side. And I'm going to try taking the reciprocal of the numerator. So let's try that and see what happens. So I have 1 minus sine theta over cosine theta. So the reciprocal of 1 minus sine theta is 1 plus, I shouldn't say reciprocal, sorry guys, the conjugate of 1 minus sine theta is 1 plus sine theta. There we go. And what I do at the top, I better do the bottom. So now I have 1 minus sine theta over cosine theta times 1 plus sine theta over 1 plus sine theta. Okay. I have the difference of perfect squares now in the numerator. So I take the first term and square it, which is 1. So I have 1 squared minus, and I take the last term, which is sine theta, and I square it. Okay, so when I do that, I get 1 minus sine squared theta over cosine theta times 1 plus sine theta. Okay, alright, so I'm going to bring that over here. Alright, so now I can use Pythagorean identity. Remember that sine squared theta plus cosine squared theta equals 1. That's Pythagorean identity. If I isolate cosine squared theta, I get 1 minus sine squared theta. That's what I have in the numerator. So what I'm going to do is I'm going to substitute in, because of Pythagorean identity, 1 minus sine squared theta. I'm going to substitute that in as cosine squared theta. Now, this is over cosine theta times 1 plus sine theta. Okay, so I can cancel out a cosine theta. So in the numerator, I'm left with cosine theta over 1 plus sine theta. And that is my right-hand side, so I've just established this identity. Okay, so that worked that time around. Moving on. There's helpful tips at the very end of this. So there's some guidelines for establishing identities. It is always preferred to start with a side containing more complicated expressions. So look for the harder side of the two. 2. Rewrite sums or differences of quotients as a single quotient. So guys, you have to find the lowest common denominator, build up each fraction, or irrational expression, and then what you're going to do is usually do some kind of substitution. 3. Sometimes rewriting one side in terms of sines and cosines only will help. Usually when you see tangent or cotangent or secant, go ahead and rewrite everything up in terms of sines and cosines. 4. Always keep your goal in mind. As you manipulate one side of the expression, look at the right-hand side of the expression. I gave you an example where I did one and it wasn't working out because I wasn't getting close to what the right-hand side of the expression was. If that happens, stop and then try a different technique and see if that doesn't do the trick. Okay? And I'm going to add a number 5. Know your trig identities. Like the back of your hand, okay? So make sure you know, like secant, for instance, is 1 over cosine. Things like that, okay? So if you know your trig identities, it's going to be very, very helpful for you. And 6, use legitimate math, okay? So don't make up some math. Like, for instance, you can't do something like this. Okay, so if I have sine theta over sine theta minus 1, I can't cancel these two out. The reason why I can't do that is because you have a monomial over a binomial. That's not legal. The only way to cancel out a binomial, and binomial, by the way, means 2 terms, is when you have the exact same binomial. So now this is legal, okay, but I can't do this. So this is simplified down, okay? So don't do some crazy math or, what I call, interpretive math. You can't do that, okay? All right, so that's it, and I just wanted to tell you, make sure you, just practice these. They get easier, I promise you. They're hard, at the beginning, but as you do more and more of them, they become easier, and you start seeing the patterns right away. All right, that's it. So you're done with 8.4. Congratulations.